Yeah. Good evening. Mhm.
Hi, Nestor.
Good evening, sir.
Hey, Charles, what's up?
Good, sir.
Hi, sir.
It is important to address this information.
Mr. Shan. Sir.
Evening, sir.
What a one.
Then I traffic ahead home, you know.
Ah, trust me. You'll be
Oh,
fine. Just
so
make sure.
me, you know, talk to.
Oh, don't say that. Jeez, I'm Kelvin. You know, so me just come back on the phone.
From me, come here and say, good evening, sir. Hi,
Oh my
sir.
God. Kelvin,
What is
me
happening,
ask you one.
sir?
Me ask you one question. Me want to ask you one question, honey bunches. One question I'm gonna ask you. Last week Thursday, you hot out for me, and today again you hot out for me.
Sir, I never I thought you last week, Thursday.
Jeez, I'm father. Somehow
Never
I don't
last
feel
week, Thursday.
Oh, true. Yeah, you didn't under manners last week Thursday, don't?
Yes.
True. but it did hot out for me in our little WhatsApp chat though.
No,
no,
it
man,
was last week, Tuesday. I thought for you.
Last week
When you
Tuesday.
never
See, I knew it.
When you never answer me, but when Charlene come, you bright up and perky up and I mean,
Oh
maybe
my
I'll write it on the
goodness.
second one, this. But it's all right. It's all right.
Oh my goodness. I'm telling you. I love it. I love it. Today is going to be a fabulous day though. Wanna believe that? It's going to be a fabulous day. We have a lot to do. And again, ask a question. A matter of fact, I'm going to ask you the question first. There's a question that I'm going to ask. And I'm going to see if how many of you would make me proud today. Would make me actually proud today. Let me just
answer question. I'm on the road.
You're on the road? All right, no problem. Let me just disconnect this one here and use the other one because I'm straining to hear from the cell phone. Let me just leave here. All right. Are you hearing me?
Loud and clear, boss.
Okay. So I am not hearing anybody. Hold on. I'm not hearing a soul. Let me just check in. Audio settings. Hello, somebody can speak for me, please?
Loud and clear, boss.
All right, hearing you guys know. All right, so you know, I have my little doobs to my sister. A gentle reminder, remember the notes. I was like, yes, and I sent it off. And as I was going through the notes, I said to myself, you know what? I am going to see in class tonight, and I know I have honest students. So if the answer is no, you're just going to be very honest with me. When I sent off the notes and I looked, and there were like about 8 questions that I did for you using the first principles, I said to myself, I'm not giving any instructions for them to go through. Here my question to you now. How many of you attempted the all 8 questions on the handout? 7.
Sir, me did under manners, remember?
Yeah, true. Ryan, how many answered?
Well, sir, to be honest, you know, me never something there because I drop us even the last hour of the class.
Lord Jesus, forgive him, Lord.
No, but me catch up. I watch video and catch up. So
okay, great.
Yeah.
Great. All right. Anybody did 5, 4, 3, 2, 1?
Class, you get manners, boss.
All right, cool. Yes, Nesta.
Sir, may I be honest with you, sir? I don't know if you make, I don't know what's wrong with me, sir, but every time I look at me, I was trying to catch up because I had some internet issues, so I was behind. Sir, but when I look on it, sir, the letter them, when I look on it, it just confused me. Sir, everything look mixed up. I don't know I don't know if something wrong with me, but everything look confusing when I look on it.
Don't worry about it. We're going to sort it out today. Don't worry about it. Matter of fact, yes, please.
But just want to second something where you need, me know say you need to look at passing grade when she made the comment the other day in her class. But I tell you, you know, you really can't teach in a boss, big man thing.
All right, thank you, Papa.
When I watch videos and I go back through, trust me, the clarity and the explanation, top notch.
Bless up. And you know, as I said, I mean, I'm
Sir,
not
me
one.
have one co-worker who asked me if you teach outside of Excelsior, because they need to come join your class.
No, man. But you know, I am, you know, self-praise is no recommendation, as you know, the cliche says, but I take pride in my stuff. You know, I got up from, if you remember, I told you that I made a blunder with completing 2 units and figuring that I was still in unit 1 because I had put some of the unit stuff in the unit 1, and I said to myself, no, I'm going to separate the notes, and I separated them and my stuff. But you know, the truth of the matter is I teach the way I would want to be taught. I teach the way I would want to, you know, to be taught. I've come across some teachers who, you know, and I don't think I'm a slow person, but they just didn't come across to, you know, to meet me. And the truth of the matter is, I have some friends who make a whole lot more money than I do. When I say a whole lot more money, they are in top managerial positions, calling the shots in the private sector, and they're making 3, 4, 5 times as much as I'm making. And they keep saying to me, "Yeah, idiot, why you sit down in a teaching?" And I say, no, guess what? At the end of the day, when I do something that I love, and if one student out of 1,000,000 students say thank you, you wouldn't understand what I feel. And I remember when I came into teaching, I said to myself, 2 years, only 2 years I'm going to spend in teaching. And funny story, I was in Burger King by the transportation center. Transportation center would never build up in time. There's still the theater that was there. And I was eating a meal, and a gentleman was, you know, a little lad was sitting across from me. But I recognized he was looking at me to see, you know, I was wondering why he was looking at me. And then I said to myself, you know what? I'm going to make a hasty retreat. So I stopped eating, pack up the stuff, and I'm about to leave. And just when I was leaving, he came over to me and said, "Are you Mr. Shan?" And then I said, "Okay, this is strange because I don't know you." And I said, "Where would I have met you?" And he said, "Sir, you taught me at Excel." I said, "Me? Teach you?" I said, "No, I haven't." He said, "Sir, you taught me 6 months at Excel. And I'm sitting here looking at you because I didn't know how to approach you to say thank you." I said, "Thank you for what?" Because even to this very day, I don't recall teaching that young man. And he says to me, "Sir, you taught me. And I got a grade 2 for the 6 maths, and I'm now at CMI. Now, this is not, it's the same CMU, no, but at the time it was an institute and not university. And he's there at CMI doing some shipping logistics, something, and that was his dream job and support and so on." And I was like, okay, great. Still no have a clue who that is, but he was able to call me by name to say, you know, I am just one person, and I've taught so many of them. And I'm going to tell you, when I left Burger King that day, I said, okay, 1 more year. And that 1 more year has now turned to 20 plus years. All right. So I do what I do because I love it, and I love when students excel and, you know, do very well. You know, it's just a part of it.
Make sure you don't forget me, sir.
No, Miss Kelvita, you? Oh, me forget you.
See, I'll get it wrong already. It's not Kelvita.
You know, I had to call Kelvita's name about Charlene. I had to call Kelvita's name about but they say Charlene, she's going to say, it's only Charlene name alone, you can't call. So that's why I had to call it Kelvita. You believe that a while ago? Father, forgive me. All right, let's go. That was our little
Sir, get himself in that trouble.
Trouble. All right. Yon, bless the heart up. Bless the heart up. All right. So let's go. So
Sir, before you start, Mrs. Something in Eddie software kind of mad me, you know, as first me see them letters there. I posted it in the group, but it says, find the limit when x tends to -4, 1 over x in bracket equal -1/x, and my e sign equals 0.08. Find one next letter thing is that's too much letter for me.
All right.
How that one they go?
All right. I will talk to you about that one. So a little confession. So I have been doing, as I said before, you know, when I made a blunder of doing the unit 1 and unit 2 together, and I decided that I'm going to separate the notes, I had to go back to the course outline. And when I looked closely at the course outline, and I can show you what it is that I'm talking about, because when I looked closely at the course outline, I got very annoyed because I'm saying to myself that this course outline is, Lord have mercy, I want to say something. This course outline is not what, is not what I am. It's not well written. So I stopped doing what it is that I was supposed to be doing for you guys, and I went ahead and I converted the file into a Microsoft Word document, and I sat down for most of the day. You see all these things that are highlighted are things that I have retyped for the syllabus. Some of the stuff wasn't typed properly, so when you look at it, you the student may not know, but me the teacher looking at it, it just never look. It's very sore to the eyes. So I sat down from about a couple of days ago into today. I don't do this thing yet. You see, when you look at these things, you see I can move up and down into the thing. You know, you're not supposed to do these things, because if you do so, piece of something gone under there, so, and you know, undo, and you don't want those things to happen. So when you use my software now, when you click on it, you have to use the software in order to get the stuff done up. So I went through the syllabus and I look at the stuff. This was poorly written. When I say poorly written, I sat down to myself and said, what them expect me to do when me I teach that something here with the students? And I look at it and I said, oh my goodness, I that them want me to do? So I went in and I typed the things properly. This one I don't reach down here say yet. And somebody asked me, for example, sir, L'Hopital's rule, you have not yet done L'Hopital's rule. I'm seeing it here. You notice EFG. You notice there's no G on your outline because I took off L'Hopital's rule from here. So what I'm doing technically is revamping the syllabus, and then through the Vice Principal of Academic Affairs, I'm going to submit the syllabus to CCCJ for them to submit it to the other places so they can look at it and you know, substitute this one for the one that they have in there, because it's not very well written. Let me just point out something here again. So L'Hopital's rule, somebody in class went on Edico and saw L'Hopital.
Sir, still not seeing a screen.
Oh, I knew that. Why am I not sharing? You seen it now, right?
Yes, sir.
Right. So I had to go and type all of these stuff. When I looked in the stuff, look, let me just point out something here to you to show you what I'm talking about. This is Unit 5. Unit 5 says differentiate single variable algebraic functions, differentiate implicit algebraic functions. Unit 4, no, 9. That's unit 5. This is unit 6. Unit 5 says differentiate. Unit 5 says to differentiate single variable algebraic functions and differentiate implicit algebraic functions. Unit 6 says, oh Lord, it's not there now. Evaluate integral as a function of the limits. All right, so this is where I'm at. So unit 4 says evaluate integrals with functions as limits. Unit 5 says evaluate integrals with functions as limit. Part 5 of this one says evaluate definite integrals. Part 5 of this says evaluate definite integrals. Part 3 up here says determine indefinite integrals of algebraic functions. This says determine indefinite integral of algebraic functions. Recognize the integral as a third antiderivative of a function. Recognize the integral of the antiderivative of a function. So it repeats. So what I teach you right here, I can't reteach you here. This one says integration. But down here now says applications of differentiation and integration. So what I should be teaching you here now would be the application to integration. All right. So this piece here now needs to be fixed up. And let me tell you why I'm telling you this. I'm telling you this because when I see this, and if you don't believe me, I gave you copies of the calculus one, so you can look back at the units 4 and 5 to see that it's the same thing that is there. I don't want somebody who is setting an exam paper extrapolate from something and put something on the paper that Sir Shan never got through because it was not stated explicitly on the exam, on the syllabus. All right. So this is why I took it upon myself to say that I'm going to be doing it. So I think this is where I started today, if I'm not mistaken. Yes. So it says differentiate single variable algebraic functions. Now, I am giving you this as the application of differentiation because we did actually find these stationary points on the exam paper. So this is an application of differentiation, and then I'm figuring that the application towards integration is calculating the area under the curve. They will give you drawings and then ask you to calculate area under the curve, which is an application to integration. So all of them, something here, 3 right down to 6 is the same thing as all of this here, 2 right down to 5, right? All it's the same thing. So I am in the process of just revamping. I have done all of that, and I have done this. So this is where now I put L'Hopital's rule, and I put L'Hopital's rule under here. So because if you look at L'Hopital's rule, you see it have F dash and D G dash and F double dash and G double dash. So you hear me speak about, yes, Kelvito, more letters. So you have F of X, G of X, then you have F dash of X, G dash of X, then F double dash of X and G double dash of X. So this here, the single dash is the first differential and the double dash is the second differential. Now I can't put it up top here, so when I only just start teaching the differentiation in unit 3, because that's where we are now. Differentiation only come in unit 3, and all I'm doing in unit 3 is just first principles. Not unit 3. Yeah, unit 3. All I'm doing is not unit 3, sorry, unit 2, right here. All I'm doing is first principles. I have not yet gone to the unit 3. I'm going to touch unit 3 today. I have not gone to the unit 3 to show you differentiate single variable functions and using all these lovely rule, the product rule, the quotient rule, and the chain rule, right? I haven't done that yet. So there's no way I could have taught you L'Hopital's rule up in here, so when I'm doing limits. Yes, L'Hopital's rule speaks about the limit of a function. See, comes back to the limit of a function, right? But having done the limits with you already, when I do differentiation with you, I will just go back and say, recall from the limits of a function. So what I'm actually trying to do, the point I'm making, I don't know if I'm making any sense, but the point I'm making is just trying to help them to structure the syllabus in such a way so that it becomes a little better. So instead of me doing the thing about today, I, finishing making my notes for you today, I was here doing CCCJ's work. All right. Now, I must do a little bit of, oh Lord, 5:30. All right, you know what? Let me do a new share. I get the sense that persons are trying to understand the first principles and are not fully there yet. So let me just go back up and do 1 or 2 of the questions. I gave you a homework. I did a homework question for you, so I want us to just go through. All right, so I did 1 and 2 in class. Just as a piecewise, when we did piecewise, that was piecewise continuities up here. I'm hoping. There's a whole heap of notes gone through already, All right, so let us do the homework question. All right, now importantly, guys, remember when Sir gave homework here is not because we don't have anything to do, it's because I really want you to get your practice. And it is in practicing you will be able to understand what is happening. So differentiation is when we did limits, I spoke to you about the intuitive approach. And having spoken to you about the intuitive approach, I was able to show you how we're using the calculations method or the algebraic approach in doing this stuff. So all of you know that if you're finding the limit of a function as x tends to 2, that you're going to assume that x is equal to 2. Nobody's going to go through the intuitive approach. Why? Because Sir would have already shown you what it is that we're doing and how for you to interpret it. Similarly, we use that level of interpretation when we're looking at the one-sided limit, the left-hand side and the right-hand side of the limit, when we're doing like a piecewise function. Now, first principles differentiation is just taking things from limits, taking our calculations from limits. There are other methods that I can show you, the quotient rule, the product rule, the chain rule, and trust me, I have a lovely story to tell you about those that you can't forget. To be very frank and honest with you, those stories still remain with me after these many years of doing them when I was at your stage of development, not age, but stage of development. So it is just taking things from grassroots end. This is what we do, and it gives you a better understanding and helps to develop your algebraic skills. So there's a past paper question in 2018 that says differentiate f of x, which is equals to 3x squared minus 4x from first principles. Now, I always like putting this thing here because I want students to copy. Every question you write it down, put it down so you can see what it looks like. Peace. All right. So what is happening here is when I'm differentiating from first principles, it's going to be the limit as h tends to 0 of f of x plus h minus f of x all over h. And remember the story? The story says that I'm looking at my incremental change. I'm looking at a change, an incremental change in my function. And when I put that incremental change to the function, then I'm going to subtract the function from it. And then I'm going to be left with the incremental change. That incremental change is going to be the rate of change. It's going to be the rate of change. All right. So when I talk about differentiation, it means it's me calculating the gradient. It's me calculating the slope. Let me just, where do I find my implement? Okay, it's right here. Let me just draw something to the side of this thing here and just show you what I'm talking about. This explanation never came to me until just know that I am trying to give a different angle to the explanation. And let me just leave to the side here. Come on now. Aye, aye, aye. All right. You know, all right. So as I speak about that incremental change, let me draw it. This is one draw now. I'm gonna draw it inside of it. So call that 1. Call that 5. Call this 1. Call that 7. All right. So when I'm looking at my slope, S-L-O-P-E, which is the same thing as gradient, right? When I'm looking at that slope, and if it helps, you're going to Outros Rios or Montego Bay and take North-South Highway and you reach a point along the journey where it is that you have to go climb, and you know, if you have a Betsy, you have to go turn off the AC and you know, open the window because the car will feel like it now move and then something there, and then when you look on one look orange or yellow sign, whichever color you want to call it, you see them have one little triangle, something looking like that, and it have one little arrow that says 6% or 8%. It is referring to the slope that you're traveling, how steep it is that you're traveling. And remember, when it math is life, you know, the study of mathematics is real life. The good things them you have in life is because of maths. So what the man them did do is cut into the mountains, literally cut into the mountains in order to construct some roads, right? And in cutting through the mountains now, what it is that you see is the exposure of the lithosphere, and the lithosphere is damaging, which the lithosphere is just really the earth, and it is damaging. And you know, when you go on the highway, you see with the heavy rains, you see how, you know, the land slippage and them something there. Yeah, man, all of them something there. So look at what I'm talking about. In order for me to calculate that gradient, that slope, that gradient or slope, I use them interchangeably, right? I am going to call this my y2. I'm going to call this my y1. I'm going to call this my x2. I'm going to call this my x1. I'm going to call this my rise. I'm going to call this my run. So when I'm calculating the slope, my slope, S-L-O-P-E, is actually my rise over my run. How far it is that I am driving on this north-south highway and the distance underneath it. How far up me I drive and the distance. So this ratio tells me the slope of it. All right. Now, how do I calculate the rise? The rise is the rate of change. So it's y2 minus y1 over x2 minus x1. So this is the change. I am looking at the change delta y, the change in y over the change in x. So this is what I'm talking about when I speak of f of x plus h minus f of x, right? So the f of x plus h is what is going to include the change. And then I'm going to subtract the change from it. So all I'm left with is the change. Think of it this way. You go foreign, you buy 2 shirts, and you decide to say, come sell me the 2 shirts. You pay $5 for the shirt, but you decide to say, you know what? Sorry, I'm a real G. I'm going to sell it for $10 each. So I buy the shirt, I'm going to give you $20 US. Mark you, it costs you $10, but you are charging me $10. So you're making a profit of $10. So what it is, in order for you to make that profit, you have added an increment to it. The shirt costs $5 each, but you are adding an increment of $5 each. So when I pay you your $20, you are taking back out the money that you spent. So what is left is going to be your profit. What is left is going to be the rate of change. Does that make any sense?
Yes, sir.
All right. So that's exactly what it is. And you know, some time ago, I tell people, you know, I always want to go into the arcade to go gather the little eagle at them and tell them, so come here to teach them some little mathematics. Because you know, the truth is, as I do that example with you just now, a lot of these persons who go and, you know, sell clothes and so forth, when you go to town and you buy one shirt from them and you or on shoes and you pay them a $1,200 or $2,500, them take that $2,500 and them blow it up. It is spent off within the day and so forth. Really and truly, and that will happen. They must have a formulation in their system to say every money that I make, 10% or 15% or 20% or 25% is going to go back into the business. Because what you find happening is that these persons know sell off to something, and when them stop, them stores or them stalls supposed to restock, them don't have no money to do it. All right. When they want to go back to Panama and Curacao and Miami and them good place, them don't have the money to buy them plane ticket. Or them can buy the plane ticket, them don't have the money to buy, put up them accommodation. So when you sell $2,500 worth of something, what you should be taking out is the rate of change, which is your incremental change, which is your profit. And then the principal that you put back the principal into your business. And this is what makes a good business remains viable, right? So this is what it is. We talk about the rise over the run. It is a change in Y that we are concerned with, and the change in X. It is a change in Y and the change in X. And a little later on, you'll see me speak of something called dy by dx. It is the rate of change in Y, the piece here, over the rate of change in X, the piece here. And this here is actually the gradient, which is the same thing as the slope. All right. So when I find the rate of change of one variable with respect to the next, it means that I'm finding the gradient or the slope. All right. So that's exactly what it is. So when you look at first principles, you're just going from grassroots. First principle speaks of you going from grassroots in order to get what it is. Before the class ends today, I am going to tell you a lovely story, and you're going to see these stories coming to light. And you're going to say, John, oh, sir, are them things that they are gone? I promise you, if you don't say that, Kelvita is going to buy us lobster for lunch tomorrow. All right, let's go with the homework. So it says differentiate f of x, which is equal to 3x squared minus 4x. Remember, the formulation says the limit as h tends to 0 of f of x plus 8. Sir, stop. Where did h come from again, sir? Thank you for asking me. The h is my incremental change. Remember, I talk about the change in y. Look here, so yes, so we start. I'm gonna go for yes, so we start in a way, you know. Yes, so we start in a way, and then we move all the way up here, so now to the end point of y. Oh, you know that, sir, Sita? My y1. My y1 is where we start, my y2 is where we leave. And then now what I'm interested in is this distance, the change in y. We start right here, so I'm in right here. So what's the change right here, sir? Sita? That's my rise. That's my delta y. We start right here, so you know, and then I come right here, so I'm looking at the run. It means, say, I'm looking at my change in x, delta x. And this is what gives us the dy by dx, the change in y over the change in x. How we get this h? This h is going to represent the change in the function. It's going to represent the change in the function. All right? So anytime I see x, I'm going to add an increment to it, which is my change. So look at what is going to happen. 3x squared is going to be 3x plus h squared minus 4x plus h. Because when I look at my function, I am going to substitute my incremental change inside of it. See just so? 3x squared is going to be x plus h all squares minus 4, see x here, x plus h. And then I'm going to minus now the original function. I'm subtracting all of f of x. I must subtract all of f of x in order for me to see what is happening. Why, sir? Because I take out the something. Oh, sir, me see, no. Because it's a y2 minus y1 and x2 minus x1, you have to subtract, sir, to see what is left. You. That's exactly what I'm doing. But in so doing, I'm finding limit as h tends to 0. Okay, so it comes with a lot of algebraic practice inside of it. And what we need to do now is to go ahead and sharpen our skills on the expansions. So, oh no, sorry. No, I'm selecting you. We're supposed to do this. All right, so what I'm doing here now, I'm saying x plus h all squares. Now, guess what? It now changed from the last time I showed you. And x plus h all squares is still going to be x squared plus 2hx plus h squares. I showed you how we got that the last time. Check the notes up top. See it right here. So I just substitute in this x plus h all squares by removing the squares, and I'm expanding it. This is a factorized form. I'm expanding it. I can't multiply this 3 by this x. Neither can I multiply this 3 by this h. Why, sir? Because it is a square. Then, sir, all of them something that in mathematics? Absolutely. Remember this? Sorry. Remember this? BOMDAS. In big school, I like to call it PEMDAS. Sir, why? Brackets? We want some big, so we call it parentheses. All right? What is O, sir? It is the order. It is the order of what it is that you're doing. Me call it exponents. And on me call it, you know, in America, them call it PEMDAS. And in Jamaica, we call it BOMDAS. And the same MDAS is the same, multiplication and division before addition and subtraction. All right? So I have to work out my parentheses first. See here, so my other parentheses, so I have to work out first. So I have to work out this first. And in order for me to work that out, that piece out first, I have to remove my square. I can't do anything before I remove the square. So that's why I have to do this piece first. Now it is that I can go ahead and do this multiplication. All right. So this is the only thing that I'm going to be expanding, because all of this I would have written back here. All of this I would have written back here. And of course, my h. Now, what is important that you have to always carry a limit as h tends to 0 right across, because you have not yet found the limit. All you're doing is just simplifying. You have not yet found the limit. So you can't not write the limit as h tends to 0. So now that I have that piece, what I'm going to be doing now is distributing that 3 into my parentheses. Distributing it means I'm going to multiply it. We just want to use big word, eh? I'm going to use a 3 here and multiply by each term inside of the brackets. Watch it. 3 times x squared is 3x squares. Sir, why put it in blue? Soon tell you the story. 3 times 2hx is 3 times 2 is 6, 6hx. 3 times 8 squared is going to be 3 8 squares. We're done with that term here. Then no, I'm gonna put back this. This negative sign says it is -4 that I'm multiplying by. So watch me. It's -4 times x is a -4x. So about that in pink, soon tell you the story. -4 times h is -4h. I finished with that term. And then I'm going to use my final term. There is an imaginary 1 outside here. So I'm going to say -1 times 3x squared is going to be a -3x squared. And this -1 multiplied by a -4 is going to give me a positive number. Oh, so sir, when you're multiplying two numbers and the signs are the same, you will always get a positive number, aren't you? When I multiply two positive numbers, my answer is positive. When I multiply two negative numbers, my answer is positive. Then, sir, or when you get the negative sign, when you get the negative sign, when I multiply two numbers and the signs are different, one number being positive, one number being negative, one number being negative, one number being positive. All right. So when I multiply this -1 by this -4x, I'm going to get a positive 4x. Now, the story is all of these terms that I'm taking out, the 3x squared and the -4x, see so? These must be able to cancel out with something there because I have to remove it. I put a t, I have to take it out. So this 3x squares, see here, cancels with that 3x squares. I color code it because I am not in front of you to show you that I'm actually canceling out. So I have to be creative and use some colors. And this 4x is this 4x that I'm canceling out. You notice this is a -4x, and this one is a positive 4x, and this is a -3x squares and a positive 3x squares. So I'm removing those because those cancel out each other. All I'm left with are those in black. And incidentally, you notice every single one of them that I left with are the ones with my incremental change. See here, talk truth, sir. Yeah, man. See here says true. Then I'm now able to factorize a h from there. And when I factorize the h, means I'm taking out the h, I'm going to left with 6x, and you can see that right here. So I took out one of the h up here, so I'm going to left with 3h. See it right here. So if I took out the h from here, so I'm going to be left with -4. See it right here. So then the h here, so cancel this h right here. So all I'm left with is 6x plus 3h minus 4. No, you see how life is, guys? It's right here. So I start doing limits now, you know. All along, I was not doing the limits here. So then, so you have to write it, yeah, man, because we have not yet done the limits. We have not yet found the limits. It's when we reach right here, so now I'm going to say, okay, h tends to 0. H tends to 0. Oh, sorry, you can just assume that h is equal to 0. Yeah, man. So anywhere in this, now I see h, I'm going to put 0. So I'm going to get this to be equal to 0. So I'm left with 6x minus 4. Then I'm finding the limit of 6x minus 4. Oh, sir, I know that. When you find the limit of a constant is a constant itself. 6x minus 4 becomes a constant because it contains no h. That means we can write back 6x minus 4 as the answer. Very good. So my answer here is going to be 6x minus 4. I'm going to pause. I said, I'll flip a while ago. Go ahead.
Sir, repeat, or you get the 0?
Anywhere in the function I see h, I'm substituting 0.
Why?
Teacher, h tends to 0.
Okay.
H tends to 0. H tends to 0. Yeah, man. I'm finding the limit at that point. And it always is the case. You notice, sir, a while ago said I'm going to copy this up here. If you look at all the questions that I give you, I just copy it and put it there because this is something that you must know. You must know. Yes, please.
The expansion about a bit, you know. Tell me expand the second line again, right? This so you're gone.
It's all right. It's the same thing that I'm showing right here. So I did a recall for you here now. So recall x plus h all squares. X plus h all squares is the same thing as saying x plus h times x plus h. Magic. Yeah, man. Yeah, man. And the good maths them you study, you know, so you know you don't get it. Very nice. So just follow. Oh, cockroach. All right, let me just get rid of this thing here because it is going to mess up my document. And all right, so let me get rid of it. All right, got rid of you. All right, so yeah, man, just go through this stuff. What I try to do, as you would have seen, you know, every time I come into the document, I'll just do the document. I will think about what it is that I'm doing. I'll try to give you some explanation in the document, but as the questions come, I'll put some other stuff in there so it is that you can always have it to refer to it. Let me pause because I'm still not moving on to anything else because I really want you guys to digest it. And I will just say that I don't want anybody to sit in and you're not following and you're not seeing anything. You need to speak to me. Ryan says that he was able to go back and watch the video. I am trusting that you guys are getting an opportunity to watch the video. The last video that I did, I kind of label it and call it First Principles, Differentiation and Continuity. And I'm going to see if I can find the time, I will see if I can just go through the videos and just, or going forward, when I'm saving the recording, I will put the title of the video so that if you're having a difficulty, you can just go into the channel and just look for that specific video so it is that you can look back at the class. I'm just trying to make life a little easier for you. But it is important though, guys, that you start working now. The truth is, the honest truth is, I am actually now putting the notes together for the Calculus 1. And it is in my preparations, writing questions and, giving explanations of different stuff. I recognize the number of different things that the Calculus 1 includes. A whole heap of topics it includes. And I don't want anybody to think like this is going to be like a psychology course where you can just go and read and you're good to go. You have to practice. You study the maths first and then you practice it thereafter. So I want you to start working now. My mother tell me, says, sir, exam going to be X time. No, I'm not care about that. Start from now. All right, question. What is the comfort level? Are you, oopsie daisy, are you understanding so far what it is that we are doing here, what it is that we're doing here?
Sir.
Go ahead. Okay, you said yes, sir. Thank you, Krish. You said yes. All right.
Sir, you can hear me?
Loud and clear.
Sir, the only problem for me is the factorizing, and that's what I'm working on.
Hold on a minute.
Sir, can I go over?
I can. Do me a favor and just look at it. I'm gonna put it in a form that you can look at it first, and then I'll be more than happy to go over for you.
Okay, I just came, that's why.
Oh, okay, that's all right. That's all right, man. Okay. So, where am I? Which one we did? Oh, the past paper one is what I started off with. Don't worry about it not seeing them something here properly. Just look at what it is that we have here. This question, past paper 2018. Give me about 2-3 minutes. I soon come.
Anybody hearing me? Sorry, Gone.
Yeah, I can't hear you.
Huh?
Yes, I can hear you and your music.
Boy, you party me there now. Sir, give us work to do.
No.
Yeah, there's a question at the bottom that we should be doing.
Oh, really?
Yep.
Oh, the same I come back to explain. Okay.
But he said we must do that question in the meantime.
All right.
Yanni, look at the chat.
All right, so I'm back with you. I hope you got an opportunity to look at it, and then you can ask me some questions. Oh, sorry, let me just stop share.
Sir, if it doesn't state where the limit is going to, should we automatically assume that it's 0?
Every single time. Every single time. Look here. You see what I put in red on the bunches? Oh, come on, don't do this to me. Everything, right yourself? Always, barring no other time. When you're in first principles, it is going to go to 0. Every single time. Other question. All right. Now, so I have additional questions in the document here that I'd want you to go through. I have done the solutions for you. I'm not interested right about now to go through the ones that I have done. What I would want to do is somebody can just quickly look into their past papers to give me another question on first principles. And then I have something that I worked on today that I want to go through with you. So the first 8, and it looks something like this. So I'd really want to go through number 8, the rational one. That one comes with a little bit of cuteness. So what I'll do though is to take, if you can find a question, a past paper question, I could work one more of those past paper questions, and then I'm going to jump to the rational question. When I talk about rational, it means I'm talking about fraction, eh? So I want to be able to look at the fractional one. On the fractional one, you have to call it Mr. Fraction, because you have to show levels of respect. All right, so let me just put the other past paper question up here. Nope, past paper. Somebody tell me, which other past paper are you seeing? Please. Please. Háblame. Look at your past paper for me, please. And give me another function where it is that we're supposed to be using the first principles to work it. Anybody, somebody. I just need one more.
Sir, check WhatsApp.
Thank you. that one here, no. This one says
December 2012.
December 2012. 12. TCMBER. And the function is 3x squared plus 4x minus 7. Alright, so you know, so I'm gonna do that down. 3x squared plus 4x. How many marks for this one?
5.
All right, good number of marks. And then I ask you to differentiate some functions right there. So all right, so we can get that. All right. All right, so you can look into WhatsApp, guys, for the question. The last thing in WhatsApp, you can see the WhatsApp question. I'm going to project this one so you can have something to look at in the interim. I am right here, but I'm just muting. Start now for me, please.
Sarah, check your chat.
Sir, what should we do now, sir?
Sorry, I couldn't unmute a while ago. Not piecewise. The first principles question in the WhatsApp group. 3x squared minus 4 something, no, plus 4x minus 7 something like that.
Okay.
Cool.
Sir, for this question, sir, after you, what happened to this 3 that you highlight in green?
In green, you see them cancel out, man, them disappearance. One is negative and one is positive. Whoosh! They disappear, yeah, man, them cancel it out. So that's why I try to color code them and show you everything in the square brackets, which is my f of x, will disappear. So look at the square brackets and you recognize that I have 3 terms, negative 3x squares, in this case, negative 2x and negative 3. All of those terms must cancel out. So I look into the front part of the stuff and find something to pair with them. I'm going to encourage you to switch on the serious mode, because we have to get this thing. There are times you go into the exam for 5, 6, 7 marks, depending on the function, and they will say to you, differentiate using first principles. If you use anything else but first principles, 0 mark.
Finish, sir.
And what did you get for your answer?
6x plus 4.
Bueno, very good. Ouch, I know that you. You have this one under your belt. Very good. All right, so I'm going to work this question pretty quickly, and I'm expecting by the time I'm finished, the rest of you will be finished with this question. All right, let me see if I substitute in bam, 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 4, 4, 1, 3, 4, 7, 26, 4x, plus 4, minus 7. All right, so so now I'm gonna have 6hx plus 3h plus 4h, and then it is cancelled. So I'm gonna have 3. X plus 4. Yeah. All right, so this is what my final answer looks like. Check for me, please, guys, just to make sure that you are where I'm at.
Yes, sir, that's what I got.
Nice.
Yes, sir. Yes, sir.
What's up? All right, excellent, very good. So for the rest of you, I'm going to encourage you to go through the additional questions that I would have done on the paper. Those two are fresh questions, they're past paper questions. I would have given you quite a number of those questions. However, there is a question that, even though I gave it to you, I still think it's important for me to go through it with you, because you're going to do one for me in class today. You are going to do one for me in class today, and I really want you to. I know what I'm going to do. All right, so the number 8 is what I wanted you to do for me, but seeing if I gave you the number 8 in class, and because it's long, I will do this one. I'll go through this one for you with you, and then I have 2 to give you for homework. I want to go through this one because, sorry, it may seem that I'm rushing, but I'm not really rushing. I mean, you have a lot of work to do for me. I have presented the information, and I want you now to just go and use it. I'm going to go through this one here with you, and then give you an opportunity between now and Thursday, all being well, to go through the additional questions that I have completed in a handout. So you can have a look at those. I will generate some more questions for you, as I have done between yesterday and today. And this is one such question. I want to go through this one with you and then tell you some stories. Let's go. So it says to determine the differential of the following.
Sorry, I missed the answer. What's the answer?
6x plus 4.
Okay, thanks.
So it says to determine the differential of the following from first principles. Now they give us 1 over x squared. Trouble. CHUBBLE. So whatever your mode of transportation today, just make sure you catch a good little spot, put on your mask. If you're at home, turn 30. I'm going to go through this, and I want you guys to follow what is happening. This one is the same thing that we have been doing, but this one here contains a numerator and a denominator. First, I'm going to do one with a numerator and denominator, so I want you to see, because I have more to give you. Let's go. Similarly, every time I see x, I'm going to put my plus h. So I have f of x is equal to 1 over x squared. Best believe that it's going to be 1 over x plus h all squares. And then minus my 1 over x squared, because that's my f of x. And I'm dividing that by h, as per usual. Now, look at what I did. Look at what I did. Of course, I'm writing my story right here, so can't change. Story are fixed. I will say it enough time and it still sounds fresh every time I say it. 1 over x squared is 1 over x plus h all squared. Remember, it is f of x plus h, which is this, minus f of x. I'm subtracting my 1 over x squared from here. Sir, I'm not seeing it divided by h. Why? I am multiplying in this case by 1 over h. So why you do that, sir? It's because I have the fraction part. So you see me working the fraction question by just converting this division sign to 1 over h. Same difference. It means that this is under here. If I put it under here, now you can have the h under here, and then you can think that this is the LCM for that, and it's really not the LCM. So I don't want to get confused. All right. Now I need to find the LCM. Now I need to find the LCM. Okay. So again, there are some of you who said that, sir, the factorization beating me. This can't beat you, because x plus h all squares is the same thing that we have been using from last week. X squared plus 2h, x plus h squared. So you're supposed to remember that. Suppose you can sing that. X plus h all squares is x squared plus 2h, x plus h squared. Can't lose that. See it here? I'm just expand. Sir, you have to expand this first. Yeah, man. Yes, man. I have to do the expansion part first. So this is just, it's the same thing here with the expansion, minus 1 over x squared, see here, so? And then the 1 over h, I'm dividing by that, but I'm converting my division by h to multiply by 1 over h, which is the same thing. No, I'm finding the LCM. No, I'm finding the LCM. So the LCM is going to be a combination of both. Alright, I'm going to find a nicer way to write it. The LCM is a combination of both. This and this together is going to be the LCM. It's not just x squared, because x squared plus 2hx plus h squared is one term. See it in one parentheses? Even though we have 3 different terms inside of that, is one term. So that don't make no sense. You, your wife, and your child, one family. And some of you don't have child, you alone live, your cat and your dog, one family. All right? So this family has 3 terms. There's one family here, so with another single family. This is a bachelor. All right? So is this times this will be my LCM. See it right here, so that times that is my LCM. So I am putting this, look at it this way. This is what I have here. This is my LCM. This into all of this goes x squared time, because this cancels out this to leave with x squared. X squared times 1 is this x squared. This into all of this, cancel it out, leaves x squared plus 2hx plus h squared. That times negative 1 is a negative of all of that. So see, I put it right here, so it now becomes this x squared coming to you today. That x squared minus all of this over 1 something here. You call it the LCM. Go ahead, Chet.
Sir, in the third line, I didn't see how you got the x squared. Not that part. No wonder. Yeah, x squared in the numerator.
This one?
Yeah.
All right. So
sir,
how many?
Sir, you can just go over the full part there, please, because I think I blink too much and miss all of it.
Okay,
So
no
just
problem.
run through all of the line, just ask what again, please.
I'm just trying to think if I want to. Rockstone. I'm trying to make something a little clearer. Control V, paste. I hope this don't confuse you now. Lord have mercy. It's ugly. Hold on there. All right, so let's go again. So the question is, f of x is equal to 1 over x squared. The formulation says, the limit as h tends to 0 of f of x plus h minus f of x all over h. F of x plus h minus f of x all over h. Any single where in the function I see x, I am going to put my plus h side of it. So does it do all along? Yeah. Anywhere in the function. For the f of x plus h, that I see x, I'm just going to put the h in order to get the f of x plus h. So I have 1 over x squared. It now becomes 1 over x plus h all squares. 1 over x plus h all squares. See this up? Right here, sir. Minus f of x, which is 1 over x squared. Right here, so. Sir, I'm not seeing the division here by h. Right here, so. What, sir? This is 1 over h. There is an imaginary 1 up here, so over the h. I don't like putting it under here, especially when I'm doing the, I want to put it there as a multiplication when I'm doing the division one, because I don't want you to get confused with two division signs. So I just put it as a multiplication sign. So when I divide something by 2, it's the same thing as I multiply by a half. My father sent $500 to be divided between my brother and I. So it's going to be 500 divided by 2. So it means that he gets 250 and I get 250. But what I could also do is to multiply that 500 by a half. And when I multiply 500 by a half, I will get 250. All right? So dividing by a number is the same thing as multiplying by the reciprocated number. All right? Same difference. Okay, now, so this is what I have. What is important for me to do now is to do this expansion. Sir, why do I have to expand it? We couldn't just leave it alone. No, man. You have to expand it. Why, sir? Thank you for asking. Inside of this something here, all you're seeing is this x plus h. All you're seeing is this x plus h. But look here, so. See a 2xh come out here, so. So there's another term that is hidden. Because if you look at this, you're going to say, sir, if you square this, you're going to get x squared plus h squared. That one here, x squared plus h squared. But there is an imaginary 2hx that you are not going to pick up. And you don't pick it up, wrong. So you have to expand first. And in expanding, I'm going to get this. Sir, you know me can't expand. You don't have to worry about that. We have been using x plus h all squares from last week. So you should know what x plus h all squares works out to be by now. X squared plus 2hx plus h squared. Oh, sir, are the same thing this? Will they use any other questions? Or two? Got you now, sir. And then I have 1 over x squared. See that just now? So now that I have that, I have this. I have two terms. One term here, and then this second term that is being subtracted from the first term. I don't want that. I want everything under one something. I want everything under one something. So in order to combine it, I'll have to find the LCM. Find something that binds them together. Sounds nice. Finding something that binds them together. What binds them together, sir, is when I multiply this denominator by this denominator. Oh, I see, sir. So you're saying then that the denominator is going to be x squared times all of this. Yeah, man, see, sir? S squared times all of that. Sir, how you get an x squared again, sir? This into all of this. You can cancel this, and you cancel this, so you just left with x squared. And you can say x squared times this one is this x squared. So the same thing like when we do at primary school? Yeah, not change. The one here, x squared into all of this here, the two something them, cancel out, and the good things left right there, so. And this times -1 is going to be negative all of that up here, so. Oh, then sir, why have to care about the 1 over h? Remember, somebody care divided by h all the time and never use it. You have to care about the 1 over h until you're ready to use it. Got you. Then no. Oh, so you don't know, sir. So you're putting everything together. So you know what I should do? I'm going to incorporate this line. Let's hope it works. Please keep your fingers crossed that this thing works. I actually was trying, but like seriously, I did it 4 times and it's the same thing I did. All right, good. Copy, bam, bam. All right. Hold on. All right, something not work. Something working. Nice. So, all right, so let me go back over this line now. So all of this into all of this goes x squared times. Oh, what's doing? All right, watch me now. All of this into all of this goes x squared times, because this piece will cancel out this piece and leave this piece, x squared. And if we say x squared times 1 is x squared. This into all of this now, this will cancel out this. So I'm going to have x squared plus 2hx plus h squared times it by -1. See just out? -1 times all of that. All right? So what I'm interested in now is my x squared minus all of this. This is a piece I'm interested in. So look at me. Me draw it out. All of what is here, so is right here. So now, bit more 1 over h. So I was just finding the LCM. I'm finding the LCM right there. So, all right. And then now, I'm going to distribute this negative sign over everything inside the parentheses. So negative times x squared is negative x squared. Negative times positive 2hx is negative 2hx. Negative times h squared is going to be negative h squared. Sir, you always say that the what it is that we're subtracting is supposed to cancel out, but sir, I'm not seeing where it is canceling out, sir. All right, thank you for that question. Let me see if I can show you where it's happening, where the cancellation is taking place. Every single time, what it is that you're subtracting, your f of x that you're subtracting, anything that your f of x is, you have to subtract it out from it. All right, so see here, and all that must be left after you do your subtraction is everything with an h. Every single thing with an h there. Every single thing with an h. If it don't have an h, it means that it's a cancel out. Trust me on that. So those two cancel out. So I'm going to be left with negative. And so we cancel them out right here. So I'm going to have a negative 2hx left. And then what I'm doing now, I'm going to factor out my h. Oh, so sir, I realize that you multiply out this x squared by x squared to give you x to the 4th, yes? And this x squared times 2hx squared give you 2hx cubed, yes? And this x squared times h squared gives you x squared h squared, yes. Okay, sir, if you say so. All right, you say so. Watch me now. I'm taking out the h from the numerator, so I'm going to be left with negative 2x minus h. Finally, sir, this h can cancel out with this h right here, so I don't have to carry this 1 over h again. Very good. Remember, the cancellation is not going to take place at the top end. It's at the bottom end before you can find it. Cancellation taking place, right? So always remember that. So now that I get rid of the h's, sir, I'm just going to have a negative 2x minus h, negative 2x minus h over my x squared plus 2hx cubed, my 8x to the 4th rather, plus 2hx cubed plus x squared h squared. See it right there, sir? I have all of that right here. No, I'm going to say as h tends to 0, anywhere in the function I see x, I am going to put Anywhere in the function I see h, I'm going to put 0. See it here, so? Minus 2. No problem. No problem. Minus 2x minus 0. See it right here, so? X to the 4th plus 2 times 0, x cubed, plus x squared, 0 squared. Oh, sir, that means all of this goes 0 then, and all of this goes 0. So we just have x to the 4th here, so very good. And we just have minus 2x over x to the 4th. This cancels out into one of that. And this here, negative 2 over x cubed, is my final answer. All right. I'm going to stop right here. And I think we're going to give you a story tonight on Thursday. All being well, I tell the story in the unit 3. So I hear you. When you say that again, to have to use the video for this one. Let me confess something to you. I'm a real teacher. So if you don't have any difficulties, only talk to me because I'm very real. So real I am. Yes, please.
Go up.
So me miss out a lot because I've been moving up and
see
down.
right there, so you find the LCM. You see the first way where you did have it? Me see it that way in there. When you condense it some kind of...
Yeah, it was a little, to be honest, it was a little choppy how I had it at first because I had to be going from here back up to 2 spaces up top, and I didn't want to do that. So let me just do this one. I have enough time that I can go through it again. But let me just finish what the point I was making. Chetty, is that a new question or is it the same raise hand?
Oh, sir, it's the same raise hand.
All right, cool. So I'm going to go through the question. I'm going to use about 5 minutes and go through the question. So I want you to hear me up here. I'm a real teacher, and I'm not going to, I know we don't have any of those at Access or some college, but some other institution may have some teacher. Oh, this is so easy, and how they can do this? No, we're going to tell you something. You see, if your algebra is not where it's supposed to be, you are going to have a difficulty with this type. Not the ones that we have been doing before. Now, the ones that we have been doing before is fine, or they are fine. But if your algebra is not where it's supposed to be, the fractional one will give you some problems. It's going to challenge you. And I guarantee you on that one. When I ask you, I tell you straight up. So you have to practice. And it's not that it's hard, but you have to make sure that you can see your letters. Let's go. This is a question. F of x is equal to 1 over x squared. F of x is equal to 1 over x squared. Next line, always write the formula. So you have to, always write it. The limit as h tends to 0 of f of x plus h minus f of x all over h. Now left off nothing in the formula. Write it down, give them, write it down, give me. I want to see it. Write it down. Write down every bit of it, barring none. Every bit of it I want you to write down. All right? Now, when you have done that, remember your incremental change. Your incremental change, every time you see an x again, put a plus h. Every time you see an x again, put a plus h. Right? So you're going to add your plus h to it. So I'm going to have 1 over x plus h all squares. All of this is like your x, but I'm putting an incremental change to it, which is my h. So it's 1 over x plus h. Then so why never do it over this side? Because this side, I'm subtracting f of x as it is. See f of x here, 1 over x squared. See so? 1 over x squared minus 1 over x squared. So I'm subtracting my f of x. So this line is given. This line is not bad because all it is that you're substituting. The next line is not bad because all you're doing is just expanding your x plus h all squares. Then, sir, me to know the expansion. See so? Enough time again or something. Plenty enough question again or something. We're going to do the expansion of x cubed. We're going to do the expansion of x plus h all squared. All right. And then now you're gonna write the x plus h all squares into your x squared plus 2hx plus your h squares every single time, barring none. That's what it gives you when you are expanding x plus h all squares. Then, sir, if you expand x plus h all cube are the same thing too? No, it can't be the same thing. Because one a cube and one a square. But every time you have x plus h all square are the same something them here, so you will get right in here. So same something then. Okay, got to know, sir. And then you're subtracting the 1 over x squared from it still. Yeah. All right, come. Now, so this is where I hear that I changed something that kind of make it a little bit untidy. But watch me. And forgive me, I'm not of a brain right here. Watch me. I have two fractions. We want to combine them with one common something. So the one here in the first denominator, we're going to multiply it by the next one by the term in the denominator. So it is an x squared that is going to be multiplied by the x squared plus 2hx plus h squared. The one here multiplied by the one here. See that, so? Bam. This is it. X squared times all of that. Watch the story. You notice that this here, everything right here, so, is the same as everything right here, so? Talk truth.
Yes, sir.
All right, good. Then I'm saying to myself, how many times can x squared plus 2hx plus h squared goes into all of this? Because this one here and this one here are the same, you cancel it out, and what is left is this amount of time. X squared times, sir. Okay, then you're going to say x squared times this one is going to give me x squared, and I saw me catch x squared right here, so. All right, watch the next story. How many times can x squared go into the denominator right here, so? Because the x squared and the x squared here are the same, what is left at that number of times? So it can go in there, x squared plus 2hx plus h squared times, and all of the terminal is going to be multiplied by -1. So where the negative say, oh, one negative sign is so I think one straight line. No, he broke off. So this is a negative sign. So it's times -1. That's why I have a -1 right here. So okay, sir, I understand now. Then all I'm doing is just expanding the numerator. This x squared is this x squared minus times this x squared is a minus x squared. All of this here is what I rewrite right here, so to show you that I don't need up here anymore, because this and this work out to be the same thing. Yeah. So -1 times x squared is -x squared. -1 times 2hx is a -2hx. And -1 times h squared is a -h squared. I see it better, sir. I'm happy. Watch me. The x squares then cancel out. Remember, so when they cancel out something them, all that's supposed to be left is only the terms in h. See it right here, 2hx minus h squared. That's how we're going to find the rate of change in the numerator. And then we're going to find the same rate of change in the denominator. All right, watch me. When them cancel out, all I'm going to be left with is that. Then I'm going to factorize the h. Why again, sir? Because I have an h, I'm supposed to divide it by more and cancel out. So now we can cancel the h from here to here. So all I'm going to be left with now is -2xh minus h squared. But you would recognize that from way up here, so I had expanded this into this. Then, sir, you have to expand it, sir? No. No. What do you mean by no, sir? Copy. Paste. I'm going to put it in a blue so I can see. Side work. Oh, Jesus. Time. Watch me. So the side work here tells me that I didn't have to expand my denominator, because when I substitute my h equals 0 in the denominator, let me substitute. Let me cut here, so. Let me cut it from here, so. Where did I substitute? Right here, so let me paste it right here, so. So is me not expanding my denominator right here, so? Put paste it right here, so. And then again, paste it right here, so again. But this time, when I'm pasting it, I'm going to take off the I soon finish. Give me half a second. It's based on the question that just came why I did it, why I'm doing this. Oh, and this is supposed to be age. All right. So this and this are exactly the same. No, so I say x to the fourth. It's just that I never expand out here. So, but I'm going to show you that I didn't have to expand it. I had to work with the numerator. Why, sir? Because I had to cancel out the 1 over h. So I've been able to substitute my 0 inside here. So, oh, the 1 over h cancel off. Let me take them off. All right, watch me. When all of this come out, when all of that come out, copy. When all of that come out, all I'm going to be left with is 2x for this go to 0, that go to 0, so that's going to have x squared times x squared. What is x squared times x squared? X to the fourth. So I still have the negative 2x over x to the fourth. So you don't have to expand the denominator because you end up doing less work. And of course, this is going to end up with me getting this as being equal to negative 2x over, no, x cubed, because one of the x's cancel out. One of the x's cancel out. So I'm just going to have negative 2 over x cubed. So it actually gives me the same answer as this one here. I'm going to stop there. This is 3 minutes past. It gives you the same answer. You don't have to worry. I gave you one here, the root of x. The truth is, I don't expect you to get the root of x because this in itself gave me, I had to sit down and think, how am I going to do something here? And then I had to go back into something that I don't even know if you did this sort of expansion in the discrete math and algebra. This is something that we teach in pre-calculus. So I'm going to send you
too much later. Too much. Too much, sir.
All right, guess what?
Sir. Sir, that's a wickedness.
All right, guess what? We'll soon come back to this one. We'll soon come to that one. I'm going to dismiss you. But what I'm going to do though, I don't even finish number 3 yet because I'm going to go road. And if you look into your syllabus, you'll recognize that these questions here, this one here, this, and the other 2 questions, I took directly from the syllabus. And I thought about that when I was working on the syllabus today. So I am working on this one. I don't finish this one yet. I'm going to see if I can finish it off, send it off to you. You can look at it, and then we'll have a further conversation with it. It looks hard now, but I guarantee you that, after looking at it and going through a few more of these examples, it becomes.
No, sir. A prob and stats, we get this in, man.
Give me a prob and stats then. I know you did it in one of them courses here.
Right, no.
Peace and salutation. What good? We'll talk here.
All right, sir.
Nice, sir. Easy, easy, easy.
Yes, sir.